The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, everyone. It's Mark from SolidCAM. This is day 4 of SolidCAM Live, and like always, we've got Kevin on the line. Hey, Kevin, how are you?
Good. How's everyone today? Hopefully everybody can hear us and see your screen.
Yeah. So to pick up where we left off yesterday, I think we'll be doing SolidWorks configurations. So this is a functionality inside SolidWorks. It's not necessarily something that is purely SolidCAM, but it can help you program your family of parts. Again, we're using these kind of really simple parts here because they're really, they're a good example of the simple kind of toolpath you can apply and how it gets updated whenever you do configurations. So just to show you what you could do with configurations, not how a configuration is built, but just what you can do with it, is this file here. If we take a look at what I have, it's the same sort of toolpaths we've been doing all week. It's just the profile for the holes, temporary bridges for the outside, and then just trimming off those bridges. It's the same file. But what I've done is I've added configurations to this file. So instead of just being a just this one with the 1-inch holes, I can actually just double click on this, and with a single double click, it becomes a 10-inch long linkage with 1/2-inch holes. And likewise with this third configuration, I could just do the same thing, but now make it a 5-incher. And you can see as soon as I do that, the toolpaths update themselves automatically. So this is an easy way to do a family of parts. If you had a really much more complex part, let's say you've got a lot of HSR, HSM, 3D machining kind of toolpaths, they all do the same thing. As long as it's some sort of recognition of geometry, which is probably just all of our toolpaths, they all are recognizing geometry, but some of them do different things completely. So if you have like a much more complex 3D part and you do configurations where the part is completely changed, but maybe it's still recognizing the stock and the target, that also will use configurations. And we hopefully I have a part later where we can really show off how that works. But this is basically just the same idea of our integration inside SolidWorks. SolidCAM is tied into the individual entities. In this case, for the profile, it was this edge of the solid, and for the temporary bridges, it's this edge of that solid as well. That has an ID number in the background. Each face, each line, each edge, each point has an ID number that SolidWorks is using to identify that behind the scenes when it builds it up. And that's how configurations work. That edge is still ID number such and such, but the length of that line or the whole location or that dimension, those are variables inside SolidWorks, and that's how configurations work. So let me close this out. We'll take a look at that actual file and see how we built that up. Okay, so let me just get rid of this hole because it wasn't even used in that SolidCAM file. Okay, so configurations basically works like this. You design your model like you would normally do, or if you're not designing your own models, this is the sort of thing you can do to modify the file so that if you are programming a family of parts and you're sent a whole bunch of different parts, if there is any commonality to them, you can start with one part file as your base, and then what you can do is modify just a single dimension that is the one that's variable. In this case, I have, let's say, just between the, let me just get rid of whatever this issue is. We'll just get rid of that. Okay. So the base of this is some sort of extrusion, base extrusion, where I basically told it this single slot or elliptical, whatever you call this shape, and it has 2 dimensions, the length of that line and the radius of that arc there. Now, normally inside SolidWorks sketching, you would just choose your, I guess you can't see it in this one, but this little icon here is the single slot. You choose your 2 points, and then you would just give it dimensions. To do configurations, what you can do is actually add dimensions, and then if I open this up, let me exit out of here. We'll get into the actual sketch. There it is. You can see there's that little symbol next to it. That is actually because I'm using a global variable. So I didn't actually type in this 2-inch. I just typed in the variable from those equations. And if we take a look at those equations real quick, that 2-inch was actually because I gave it an R. And that circle that we had before will show you how we use that global variable. So let me just go back into sketching here, click on that face, put that circle back on there. So all this is simple SolidWorks stuff. But as soon as I click on the dimension, instead of typing in the value, I'm actually going to just type in an equal sign, and then it brings up all these abilities here. I can choose from my global variables. So in this case, I can just choose in this case, let's do the diameter one. So I'm just making it equal to D, whatever D is. Otherwise, I could have made that an actual equation. So I have functions here, mathematical functions. I can do file properties, and then I can grab from other variables. But the point here is the use of the global variable, like so. What that allows me to do is make changes like this. So anything that's referencing D, now we'll just go and let's make it even bigger. So we'll say just 2 inches. And now those holes were using the D dimension, that circle was using the D dimension. This is one way to program the part using just equations. How that can help you with configurations is now I can go in here, and for each version of the file, each component of that family of parts, I can actually configure this for different configurations. So for this configuration, this is 2-inch. And then I could do a save, or I can go over here and make a configuration. Let's go to the top here. So add configuration. And now I can say, let's make it with 3-inch holes. So now I have a configuration called 3-inch. And in this equation section, I can say, now let's just make all those holes 3 inches. And I'll say that only is possible for this configuration. So now every hole is 3-inch, but if I go back to our original one, which was, I believe, this one, they're back to whatever well, actually the circle's gone, because that's another function of configurations. You can hide and show, or suppress in this case, different features. So if you have different hole locations or different hole patterns, or even completely different features, a good example of this is if you have a turned part that eventually has some milled features on it, you can create a version of this file where you have configurations that represent the bar stock, then the turn stock, and then the milled part, the final part. So one part file can represent all stages in that file. And then when you go and do any kind of SolidCAM toolpath in either your mill turn or your milling, you have the ability to pull up a different version of that solid. It's really useful for when you're doing unique stock inside of milling. To eliminate air cuts, you can actually bring in that unique stock that represents the turned stock, and then set that up as your stock. And then in your target, switch the configuration to its final version. And then inside the toolpath, it actually will recognize which configuration represents the stock, which configuration represents the target. And then in one part file, you have everything represented. You don't have to manipulate different files or keep anything up to date. Since it's one file, everything's fully associative from that one file into SolidCAM. Hopefully that's making sense.
I think what we should do, Mark, is let's start off with a fresh part, no equations or anything like that, and let's build some configurations right off the start.
Okay, let's do that. So how about let's just start completely fresh. Get out of here. Okay. And for those of you who don't really use SolidWorks that often, this could also act as kind of a primer on how to do solids and sketching inside SolidWorks as well. We'll just choose part file. And we'll do something really simple. We'll just do a block with a hole in it. So we got our block there. And without equations, we'll just do this as simple configurations. So we'll do a 5 by 5 block. With the thickness of, let's just do 1/2 inch. Okay, simple enough. And then let's do a sketch of a circle on the front plane, and we'll do it down the center. And we'll give this guy a dimension of 2 inches. And then we'll do a cut extrude. And we'll leave it as blind, and we'll do a 1/2 inch. We'll just do a through hole. Okay, let me just save that. Okay, so now we have a part. Let's say this represents the family of parts. This is the base model. This has our 2-inch hole and a 5x5 block. If you want to make configurations, it's actually in the top left corner here, your configuration manager. In the configuration manager, you have actually 2 things you can create here. One is called display states, and one is called configurations. This is something down here, this display states is something I've covered in a tips and tricks video on our YouTube channel. So if you're interested in what this does, you can always take a look at that video, or you can send us an email and we can forward you the link to that video. But in terms of configurations, it's kind of what we've been seeing. One file can represent all the different versions of the family of parts. So it starts off having just the one default. If you right click, you can go to add configuration, and you can give it a name. So let's say we call this one 1-inch hole, representing the hole in the middle is now going to be 1 inch. So in this configuration, we can go back, and for the cut extrude, we'll change that to 1 inch. And you can see here, as soon as we create any configurations, once there's more than one, it gives this little icon here where we can actually choose which configuration this dimension pops up in. So I want it to only be for this one. So when I click the green check mark, it changes the sketch of that hole, which, because SolidWorks is top down, changes that cut extrude. Now that is a 1-inch hole instead of a 2-inch hole. We go back to the configuration manager, and I double click on our default, it changes it back, because in this default configuration, that was a 2-inch hole. If I double click on this one, it becomes a 1-inch hole. So it's not just one thing you can change. Let's say for the 1-inch hole, now the outside, instead of being 5x5, let's just make this dimension 10 inches. Okay, and we'll say that that only exists for this configuration as well. The way that I designed my part, I actually have it centered on the origin there. So it's always just going to go and make that the center plane there. And that's another little tip and trick for SolidWorks sketching. You always want to have some sort of reference point. The origin is always a really good one to use, but as soon as you start adding additional features and you can't reference the origin anymore, that's when you add dimensions. But a dimension is a type of relationship, a type of constraint. So it also will help you in your configurations and your design. So we've got 10x5 and then a 1-inch hole. If we go back and take a look at what the default used to look like, all you got to do is double click, and then all those changes come back. So this is a really easy way to make family of parts, because it doesn't just have to be one change. It could be something completely different. So that's just with dimensions. Let's say in this configuration, the 1-inch hole, we add additional holes. So I'll just do a sketch, and let's just add some more holes here. Okay, and I'm just going to freehand them for now, no dimensions. We'll take that sketch and we'll just do let's do an extrude base. So we're going to add these bosses here. Now, if I right click on that feature, again, because we've added configurations, I now can go to configure feature, and I can say from the list of configurations here, I only want this to pop up in, let's say, our 1-inch hole, because that's the one we're currently in. So I'll just click OK. Oh, actually, I wasn't even looking at what I was doing there. If I go back to configure, it actually says suppress. So we want it to show up in this one. We want to suppress it in there. And this window also gives you the ability to actually just add a configuration on the fly. So I could just add, I can create one here, and I can just give it a name, and then I can tell it if I want to suppress it here or not. In this case, I'm not going to do that. I'm just going to apply, get out of here, and then we could just show how if we go back to default, those bosses are gone, the whole goes back to its original design. So you can configure features and you can configure dimensions. And when you configure dimensions, you can also configure dimensions using those equations we were looking at before.
Now, the really cool thing that you guys can do with configurations as well is in the assembly level, I think Mark was kind of touching on this a little bit earlier, is let's say you have an assembly with all your fixtures, toe clamps, bolts, all that. And what you can do is you can set up a configuration for your part only. Then you could set up a second configuration for your part and all your components, as well as a third configuration maybe for a second op in there, so you guys can bounce through all that very quickly without having to go through and hide and suppress and doing all this other stuff. And that's kind of where the configurations really shine.
Mm-hmm. Absolutely. Especially when you have a whole bunch of stuff, like Kevin just said, a whole bunch of stuff that you have to suppress or a whole bunch of stuff you have to show or hide. It can be a pain to keep jumping back and forth and then trying to remember what needs to be hidden, especially when you're talking about the setup for side 1 and the setup for side 2. If you had a vise on the top of this thing and a vise on the bottom of this thing, or clamps on side 1, side 2, you don't want them to be on the screen at the same time. But a lot of the times, those vices are a full assembly. There's many components in that one assembly, and you might not remember exactly which ones need to be hidden and shown. But if you set that up as a configuration, or in this case with the fixtures, you actually probably want to do it more like a display state, but they work the same way. You can actually hide and show everything from side 1 and side 2 quicker just by doing a double click than it would be to go back to this screen and try and remember which one is for side 1 and which one is for side 2. So any questions on any of that?
Nothing coming in yet.
Okay, so let's make a, we'll use the same file, and this time I'll do everything I just did, but with equations. So an equation is really easy to add. You just go to Tools and Equations, and equations could be anything. It could be mathematical equations. It could just be simply variables, and that's what I did with the other part file. I just went to Add Global Variable, and let's say we just call this one diameter, and it just asked me for a value. So let's say the value will be, what was that? That was a 1-inch hole there. So we'll just say 1 inch. And that's it. And then let's say that we have a length of 5 inches and then a width, 5 inches. So these are now variables that when I go into my dimensions, let's say I go back into creating this one again, this being my width, I can just say equals, and then now the variables pop up. So I'm looking for my width. And you'll know that an equation has been applied to the dimension when it has that little sigma symbol there, that little Greek E.
And as Mark's doing this, this would come real handy for those of you guys that are running like soft jaws. You can set up the equations that way. So let's say you're running a 2-inch part, so it would automatically update for 2-inch soft jaws, is where I've used it in the past.
And these can be variables that are tied into an assembly as well. So it's kind of exactly like what Kevin was just mentioning. So if you have a fully assembled part, the target sitting inside of soft jaws, and now you need to change those soft jaws to match what the part is, then you can just take a variable from your part file in that assembly and then just relate it to the part file from the assembly that makes up the soft jaws. And then an arc that represents something on the soft jaw could be just a value that you take from your part file. That way you don't have to go and remate everything. You can just say one face is tangent with another face, or one face is coincident with another face, and then as soon as all those variables line up, the whole thing will change, but because you've intermingled and related everything, it'll just morph itself into the shape that you're looking for. So the jaws will cinch up or expand depending on the size of the part, through your mates, through your equations. There's so much stuff you can do inside SolidWorks that's why it requires a little more training than just a half hour. But there are many different things you can do here. For instance, like I said, I just added these equations here. Now we can always go back here. We can double click on there, and if we just want to change, let's say, the diameter, Let's just go to the diameter there, and I will change that to, let's say, 2.5. Then click OK, and now that's 2.5. And I can configure that as well. So if I go into configurations, it has that same symbol we were looking at. So in this case, I can specify which configurations it pops up in. In this case, maybe just the 1-inch hole and not default. This one's the active one, so that's why we have to select it. Let's just go like that, click OK. And now every configuration is doing that. Double check what we got here. That is because in this configuration, it's not using the equations. So let's go into that guy right there. So you can see it doesn't have the sigma symbol next to it. I'll just say equals. And now if I interrelate it, now it says 2.5. So anywhere you put in any kind of dimension, you can use an equation. So if we go into the equations here, again, I'll just add a variable. And this one, let's call this one height. And we'll make the height 1/2 inch. So where I would use height is like in things like these solid bosses here. I'll just go and edit the solid boss. And instead of just being blind, I will just say equals. And then we could just say height. And now those are 1/2 inches. I can also do something like this. So if I want the height of those bosses to actually be, let's say, the global variable L divided by 2, I can do that as well. So now those are 1/2 of whatever L was. Those should be 2.5. And they are. So now all I have to do is go into equations. And then because this is all math now, I can always go in here and say, okay, instead of 5, let's make that 2. You can see that it collapsed the length of the part, and those guys are now also 1/2 of that length as well. So it's all fully interrelated, and that's the power of those equations. Let's probably make this little something more realistic. Let's make it 4. Okay. So no new questions. Okay. In terms of configurations, since we're talking about configurations, let's take a look at display states. I want to see if I can pull up that part file that I used in the video, because that'll really show off what we're actually trying to do with configurations and display states. So if you bear with me for a second, I will pull up that file.
And as Mark's pulling up that file, for everybody that is currently watching, do you guys have any ideas for next week for the SolidCAM Live class? Jake, you got to have something for us. For those of you guys that are new to this SolidCAM Live and night class, I always like to pick on at least one guy in there. So Ronnie Kidder is my night class pick on, and I'm put Jake in there as our SolidCAM Live pick on.
Okay, so you can see here I have a really basic looking tombstone, and I've got a Kurt vise there holding some stock and a target. So let's say that is side 1. That is my Mac 1 position 1. And now I want to do side 2. I want to do my Mac 2 position 1 on the opposite side, but I got all this stuff here and I want to hide it. If I go to the feature tree, I can try and remember which one of these is the Kurt vise for side 1, which one of these is the Kurt vise for side 2, or I can do all of that beforehand. And then when I go to my configuration manager, you'll notice I don't have any configurations. That's because configurations suppresses or ignores whatever you are suppressing or ignoring, things like dimensions or features or whatnot. But if you do that inside SolidCAM, if I told it that this vise is no longer here, any machine setup, any dimensions, any kind of locations, levels, or anything like that from toolpaths that are referencing those will get disrupted. So you don't want those to be suppressed. You just want those to be hidden from your view. So essentially you want everything to stay on screen, you just want it to be hidden. Well, that's what the display state is for. It's literally just for displaying. So let's say, for instance, in display state 1, this is what we have right now. We're just looking at it here. If I right click and say add display state, now I can say for display state 2, I want everything to be represented for side 2. So I will hide these two guys, and then I'll bring these guys up. Okay, and if we go back to our SolidCAM here and we just take a look at, actually it only has Mac 1, okay. So for now, let's just look at it like that. So that is the opposite side, that is the side 2 of that part file. If I want to look at side 1, again, I just double click on display state 1, it only shows the vise and the tombstone for side 1, double click on display state 2, shows the, it's supposed to show the vise. There it is. Let me open that up. There's probably something in there that's hidden.
And a good way to, at least how I understand it better, is display states are set up for just hiding and showing, where configurations work better for if you are suppressing or changing diameters and stuff like that. So display is just visually taking it away, and when you suppress something, it is physically taking it away where you are not looking, the software does not see that at all.
There's something about this solid that got corrupted, I think.
So we do have a question here.
Oh,
if I
okay.
use configurations, how is SolidCAM link remember operations geometry to SolidWorks features? So do you want to answer that one, Mark, or want to?
I guess I missed the beginning of the question.
So he's asking, when we're using configurations, how does it link or remember features and geometries? Geometry tags is kind of like, I think he's getting at.
Exactly. It's okay. I didn't call them geometry tags, but those ID numbers I mentioned earlier are those. That's exactly how SolidCAM is going to follow and remember what is to be hidden and shown, or what in terms of SolidCAM, what it's going to remember to use as the geometry to stay up to date with, to be associative with. So every feature you choose, a solid edge or a face, has an ID number, or like Kevin called it, a geometry tag. That is what is actually assigned inside SolidCAM. So regardless of the shape of that geometry, the diameter of that hole, or the location of that face, those faces, those holes, those edges are being called out by their ID number. So that toolpath is looking for that ID number and then just following that specific path. So whatever toolpath you're using is going to follow the ID tag rather than that specific configuration. No, I shouldn't say that, but that the current status of that geometry or that feature. So if you actually do a configuration where you've chosen a hole and then in another configuration it's no longer there, the toolpath will no longer see that piece of geometry, and then it will want to be either recalculated to the fact that there's nothing there, or you might have to suppress that toolpath. But there are ways to program for things that disappear or reappear. And that's a good example of what Kevin did in the KevCam this week. Those holes, eventually those holes either were reduced in number or not even there at all. And that's when the toolpath just automatically updates itself to reflect the current status of the part file.
Perfect.
Hopefully that's a good answer.
And then we got one other one. So what Jake was coming across is one thing that came up recently was saving your configuration before loading a new configurations. And he came across this when he was doing the SolidCAM certification. So just make sure you save out your configurations.
Maybe I don't get the question. Was there a question or is it just a comment?
I think it's just a comment.
Oh, okay, okay.
At least if I read that right, Jake. And as well, since we're kind of talking about the certifications, I know we're getting low on time here, but you guys do all have free passes to take the SolidCAM certification. So you can take the associate's test, or you can take the professional test. The associates is going to be more geared towards your basic functionality, milling, or I'm sorry, face mill, pocket, drilling, profile, tapping, all that stuff. And then where the professional is going to be focusing more on fourth axis indexing, some surfacing, and some 2D eye machining, stuff like that. But with that being said, Jake, is that a suggestion that you'd like to for a class for saving out settings?
Nope, just a quick point. Okay. It is a good function for when you've got a new user or you're trying to share network locations for things like your iMachining database or your tool tables or anything like that, to be able to save those global settings and then send that file to somebody else. So it is. I agree. It is a good point. It's a good thing.
All right. Well, I don't see any other questions coming through here, so we'll kind of wrap it up with today. And tomorrow there will not be a SolidCAM Live, just for holiday, Good Friday. But yeah, we will continue these on next week and having some new topics in there as well. And like I said, please, if you guys do have topic ideas, send those over to Mark. So because these aren't for us to go through. These are just to kind of help better you guys. So we want to know what you guys want to know more of. But with that being said, we will talk to you guys next week. Thanks, Mark.
Yep. Talk to you guys next week. Have a good weekend.